Hey everyone, my name is Will, and today we're going to be talking about N+1 issues. We're going to see what they are, why they're so important to your application, and how you can use Sentry to find them in your app with no custom instrumentation. So for today's app, we have a React front end that's talking to an Express API that's talking to a Supabase database out there in the cloud. A really common performance anti-pattern for something like a blog might be that we want to paginate through the first 5, 10, 20 blogs out of like 1,000, and we want to use that to populate like 20 different React components on the front end. Now, it might be easy to just write a for loop or have each one of these components have their own database query, but that might lead to this N+1 issue, where we then are creating a new query for each of these individual components. Now, this might not be a huge performance impact to the end user, maybe it's 500 milliseconds or a second or two, but to our infrastructure and to our cloud costs, this can be a real big problem because it leads to 20 requests for each instead of just one. So a better way to do this is by using something more RESTful with a start and an end. This leads to a much faster experience for the user, there's fewer database connections, and it's a lot easier on the browser. So what does this look like in our demo app? If we pull up this page, we actually have a N+1 issue pre-baked for us. By hard reloading, we can see all the network requests live, and we can see that we are triggering this N+1 query to populate all these different, React components that might be like a blog post or something like that. Now, what does this look like in Sentry? We can reload the issues stream here, and we'll see that this N+1 API issue was just triggered 15 seconds ago. If I click into it and then select last, we'll actually see all of the event information that can be useful for us to debug this. So here we have the waterfall where we have both the front end and the back end talking to each other, and we can see all the requests that both of them are making. So if I click into view full trace, we'll then see the full waterfall and why this page load took 1.16 seconds when it should have been really, really quick. If I expand out this page load, we see everything that's happening in our React app, including assembling the front end, but we also have these HTTP client requests where we're pinging our backend local API, and then that local API is talking to our Supabase instance. You can see this instance here. We can also see all the cross-site origin stuff, the JSON parsing, and all of this can be really useful for us to understand why something like this might slip through into production, right? We are requesting this same URL a bunch of times, and it's leading to a pretty costly and slow waterfall. So a lot of people might be wondering, how do I get this set up in my own application? Well, luckily with Sentry, it's super easy. All you have to do is add it to your front end and your back end, and you're done. Nothing custom about it. So here in Sentry, all I'm doing is adding it from the React repository, adding this thing called the Sentry browser tracing integration, which makes sure that the trace ID is the same across all of our services. This makes sure that this ID right up here at the top is the same no matter if it's coming from our React front end or our Express server or any other microservices that you might have set up. It's always going to have the same trace ID and will wind up in the same waterfall. This basically is just a one-line thing. You don't need to do anything custom beyond that, aside from adding the trace propagation targets. So in this case, we have our Supabase URL, we have localhost, and we have our API endpoint, just to make sure that any sort of outbound request is captured by our browser tracing integration. And then on our backend, we basically do the same thing. We have Sentry from our node repository. We are adding the Sentry Express middleware tracer, which is nice. This allows us to see the cross-site origin stuff. We have the JSON parser and we have the logger. All of those are traced. And we also have the trace propagation targets here as well, because this is where some outbound requests are being made to that Supabase URL. Now, that's it. So if you dig into this code base, it's all available on GitHub. You won't see any other Sentry start spans or transactions or things like that that you might be used to with other tracing solutions. It's all being done completely out of the box, including all of these fun issue detectors like the N+1 thing. That's just one of many different things that we have out of the box, and we'll be exploring some of those in the next tutorial.